I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, we'll discuss a very important assignment based on continuity and differentiability of a function. The concept used will be the concept of limits. It's a very important question on calculus. Normally, it is the very first question which you'll come across when you deal with limits and differentiability. I'd like you to copy this assignment questions and submit their solution. In case you want to get them checked from me or have my suggestions, you can always send an email on the address given. There are two questions here. They're being converted to a multiple choice questions. Question number 1. Find a and b such that the function f is differentiable everywhere. F of x is a piecewise function which is equal to ax cubed when x is less than equal to 4 and x squared plus b when x is greater than 4. The sum of a and b is given to you as one of these choices. I hope the question is absolutely clear. Question number 2 is an assignment question which is real life application. The question here is, a section of a roller coaster is being designed for the global amusement park. It has a track which can be modeled by a cubic curve y equals to ax cubed plus bx followed by a linear function. Find the constants a and b if the curve joins smoothly to the straight path with slope of 5 at coordinate point 10 feet, 20 feet. Product of AB is what? So the multiple choice is, once you calculate the value of parameters A and B, then their product is given to you. You can pause the video, answer, and then look into my suggestions. These questions are based on the concept of continuity and differentiability, as you know, correct? Let us revisit what continuity is. A function f is continuous at x equals to c if and only if the value of the function at c exists and the limit of the function exists and the limit is also equal to the value of the function. So these three are the conditions for the continuity of any particular function. Now let's look into differentiability. Now it is important to note that a function is differentiable at a particular point only if it is continuous there. So we do have continuity as one of the criteria. And above that, what? The function f is differentiable at x equals to c if the derivative of the function has a numeric value. That means now we're talking about the derivative of that function at that point has a value. So that gives you continuity along with differentiability. So if f is differentiable at every value of x in an interval, then f is differentiable on the entire interval. So you could have continuity and differentiability questions based on the entire interval or at a point. So if it is at a point, in that case, you have to find the limit of the function at that point. It should match with the value of the function. That gives that function is continuous. And then for differentiability, you have to find limit of its derivative at that particular function. Is that clear to you? So note, limit of derivative should exist for differentiability. Simple as that. Now, with that in mind, let us see how we are going to solve question number 1. So basically, we are given the function with two parameters a and b. We need to find both the parameters. That means we need two equations. So the first equation we can find with the concept of limit. So we have to find limit when x approaches a value. In this case, both the functions cubic and parabolic are continuous. However, at 4, they could be discontinuous. So we'll check the value of this limit at 4. A limit from both left side and right side should be same, right? And should be equal to the value of the function. So limit of this function at 4 from left side should be equal to limit of the function at 4 from the right hand side, right? And that should be also equal to the value of the function. Okay, so we substitute 4 here to find the limit at 4. So we have a 4 cube should be equal to 4 square. Instead of x, I'll write 4 now, plus b. Now we can solve this equation and we'll have our first equation. We can write b as equal to 64. 4 cube is 64. 64a minus 4 square, 60. So we get one equation writing b in terms of a. Now let us find the derivative of the function. Well, the derivative of the function is equal to 3ax squared when x is less than or equal to 4. And here it is 2x when x is greater than 4. So this derivative limit should be same, correct? So we'll now equate limit when x approaches 4 from the negative side, the left side of f of x, that should be equal to the limit when x approaches 4 from the right hand side for the derivative of the function. Substituting 4 here, we get 4 squared times 3a should be equal to 2 times 4. So a we can easily calculate from here. So a is equals to 2 times 4, which is 8 divided by 4 squared times 3. Let me write 16 times 3, right? So that goes, we get 1 over 6 as the value for a. Substituting a as 1 over 6 here, so we get the value of a. Let's call this as our equation 2. We get b equals to 64 times 1 over 6 minus 16. And that is, well, we can simplify this dividing by 2 at least. We get 32 by 3 minus 16. So that gives you the value as what? 32 minus 3 times 16 is 48 over 3, correct? So this gives you a value of b as equal to 32 minus 14 is a negative number, 6 and then 16 over 3, right? 1/3 of 16. So that is the value of b. The product we want, so we got the value of a and b. So in a multiple choice question, we were asking for their sum, right? We know the value, correct? So I hope you understand how we could calculate a and b. The concept is first go for the continuity and then differentiability. They give you two different equations, solve them for two different parameters. Here is a complete solution of this particular question. So we just found that a is 1 over 6 and b is minus 16 over 3. The question was, what is sum of a and b? So from here, we can figure out the choice. So when you add this, you get 1 over 6 minus 16 over 3 as negative 31 over 6 as your answer. So I hope you get the solution, correct? So that is how we'll do question number 1. And now Let's move on to the next question based on roller coaster ride. Question number 2. Let's try to understand the concept. It's a very difficult question. So, the question is, a section of roller coaster is being designed for the global amusement park. It has a track which can be modeled by a cubic function followed by a linear function. Find the constants a and b if the curve joins smoothly to the straight path with slope 5 at the coordinate points given to you. So cubic function is something like this, right? And we are saying at this point we have a linear function, right? So whose slope is 5 to us. You get the idea. So that is how they merge. So it's a smooth curve at this particular point. And this point of merging is given to us as, let's say the coordinate point is 10, 20. So we know two things at this point. One, the coordinate point, and we also know that the slope of the curve m is 5. That can give you the equation of this linear function. You get the idea. So let's go with the equation of the line. So if we have this line, and let's call this as L, since we know the slope, we can say it is y minus y1 equals to m times x minus x1. Y value being 20, so y minus 20 equals to 5 times x minus 10. Let's rearrange. So we get what? We get y equals to 5x minus 50 plus 20, or y is equal to 5x minus 30. So that is the linear function which is there after 10. Do you see that? So I could actually write this as a piecewise function. So I can write this as a piecewise function whose value, when it is less than 10, is what? Is given to us as ax cubed plus bx when x is less than 10. Is followed by a linear function at 10, 20 feet, right? So that is 5x minus 30 when x is greater than equal to 10. Now both cubic and the linear function individually are continuous. So we'll check at 10. You get the idea. So you can now substitute 10 in these equations and equate them using the continuity principle and get one of the equations. And second, of course, you'll find the derivative. So let me write down the derivative also. So derivative will be 3ax squared plus b when x is less than 10, and derivative for the second function will be just 5 when x is greater than equal to 10. So that is how you will get both the equations. So I hope this concept is absolutely clear. This is the difficult part, to understand how do we get these equations. Once you get to this, then it is what you did last time. Find the limit, equate, get one term a in terms of b. And the second one, again do the same thing for differentiability. Correct? So here is your solution. So we did exactly what I was telling you. So we wrote the equation of the line, which is y equals to 5x minus 30. And therefore, the function is ax cubed plus bx for x less than 10 and 5x minus 30 for x greater than equal to 10. Using the continuity principle, the limit from the left side is equal to limit from the right side at 10. Substituting 10 for x, we got our equation as b equals to 2 minus 100a. So go through these calculations, correct? Same thing for the derivative. Functionality. The differentiability is that the limit of the derivative of the function at 10 should exist. Substituting 10 in the derivative, we get this particular equation where we found the value of a as 3 over 200. Substituting 3 over 200 for a, we can find the value of b. Perfect. What was the question trying to figure out? Well, you need to find the product of A and B, right? So you know the value of A and B, multiply and then choose your answer. So that is how we are going to answer this particular question. So I hope the concept is absolutely clear. It is a very important assignment which gives you insight to continuity and differentiability. With that, we end our unit. Feel free to write your comments, share your views. If you like to join my classes, you can always write an email on the address given. Thanks for your time and all the best.